In my last video, I explained how you can use the concept of embeddings to feed your company's own proprietary data into GPT models such that when you ask ChatGPT a question, it can answer that with the knowledge of all the proprietary information that you might have that it wasn't trained on. If you want the details of this, I'll point you to the video. What we need to make this happen is an embedding model. And OpenAI does have an embedding API, which is quite affordable. But the problem is some companies might not want to feed all of their proprietary millions and millions of documents into a third-party service, which they have little control of. So at the end of the video, I showed you this Hugging Face repository, which is a collection of all of the open source AI models out there. There's a leaderboard called MTEB. MTEB stands for Massive Text Embedding Benchmark. This is a popular and very comprehensive benchmark that embedding models would test themselves against to understand how they perform against the state of the art. And of course, there are many different ways of using embeddings, for example, classification, clustering, information retrieval. And so different models might perform better or worse against different aspects of the benchmark. But anyway, they kind of, to come up with this leaderboard, they came up with, tested it against all of these data sets and all of these tasks and came up with an average score and then ranked them. So if you look at number 6, text embedding ADA 002, that is OpenAI's embedding model. And up here, you've got some really well-performing ones, E5, large V2. It begs the question of, well, it's so easy to use the OpenAI API. How much work is it to deploy one of these models on your own? And the great news is it's really not that hard. There are a number of steps to it, but I will walk you through each of the steps today. So if you, let's say, hey, we want the top ranking model. How do we get this for ourselves? If you click into it, you'll see some details. And note that the embedding size is 1024. So for every bit of text you send in, the vector that you get out has 1024 numbers. The OpenAI one is 1536. But another really key difference, and I have to say is something quite unique to the OpenAI models, is how much data you can put in. So this one, there's a maximum length of 512, let's see. I'm not sure if it's words or tokens, but basically it's one page, roughly one page worth of text, whereas the OpenAI one can take thousands, like an order of magnitude more. But anyway, let's say we're fine with this input length. So how do we deploy it? You'll see a button here that says deploy, and if you click into Sagemaker, it will show you the code that you can copy and paste into it. And you can just put your sentence here and test it out. But what you might not realize here is that the data that you get out of this, both this way and using this code, the output is not in the right shape. As in, if you put in 5 sentences, you're not getting 5 times 1024 numbers. And therefore, we need to add an additional step to the end of that, which makes things a little bit more complicated, but still very doable. So here we go. If you like to follow blogs, this one is by far the clearest one. So I will put a link to it at the bottom so you can follow along. It uses a different model than the one that I've chosen. So let's see. Oh yeah, you can see here it's chosen one called All Mini LM L6V2. But this model has the same issue as the one that I chose, which is that it needs some additional processing at the end. So you can just definitely make reference to this. So let's get started then. The first thing that you need to do is to go into AWS Sagemaker. Once you're in Sagemaker, make sure you have chosen the region that you would want your assets to be sitting in. I've chosen US West 1. Go into Notebook Instances. So what you want to do here is to create an instance where you can run Jupyter notebooks. So I already have one running here, but I will show you how to do it. So you click on Create Notebook Instance, and you can give it, any name, test, embeddings, notebook. For the notebook instance type, for the kind of models that we're running, I would suggest going with MLT3 large. Choose Jupyter Lab 3. Volume size, I suggest you change this to 10. I found that if I go with 5, sometimes it will crash. And then for permissions and encryption, choose Amazon SageMaker execution role. If you have tech ops within your own company, I'm sure they can help you with this stuff. And then encryption key. I have not chosen to use encryption in this demo, but if you're working with very sensitive data, I would recommend that you go with this KMS encryption. And that will make sure that all of the data that you're working with, even within this notebook environment, is secure. And then, let's see, network, fine. Okay, so I think we're good to go. So you just click on Create Notebook Instance, and then you will get something like, you'll get one of these. And then once you get one of these, it might take a few minutes for it to be come into service. You click on Open Jupyter Lab. It's just a slightly newer interface compared to this one. Once you're inside the Jupyter Lab, and you can choose this one, PyTorch. So if you click on that, there we go. You already have your notebook. And I will show you the one that I created before, which has all the code in it. Let me just close this one. Discard. So here we go. In this notebook, we will be deploying the E5 large V2 embedding model, which is the top ranking one here, into an AWS API that can be accessed through the internet as long as you have the right credentials. So the step one is that you need to install some packages. So we're using a package called transformers. Step 2, we have to import some libraries that we're going to need to use, namely PyTorch and also the transformers library. Step 3, we need to get or set up an AWS role. This is such that our notebook, which is running within SageMaker, has the permissions to put the assets into other parts of WS. So for example, later on, you'll see we'll need to save our model into AWS S3, and then we'll also need to create an endpoint that is open to the internet in another part of AWS. So it just needs to have permissions to do that. So let me just run these. These don't tend to take too long to run. So you'll see, here it doesn't have the little play button, unlike Google Colab, so you just do Control Return to run it. And you'll see in the step 3, what I'm doing is fetching those models from Hugging Face. So this corresponds to this. So it's saying, go get the pre-trained model from Hugging Face. So if I do this, that might take a little while to just pull that off. So this next chunk of code that you see here is not essential for the deployment process, but I just want to show you that the model actually works, right? So we've pulled the model down, and what we're going to do here is to put in just some text. So here we have a list of sentences. So we have 2 different queries: how much protein should a female eat, summit define, and then the passage, i.e. the document chunks. This first one is one that's relevant to the first query, and the second one is relevant to the second query. So we can see the embedding differences later on to see it actually working. And then what this part does is to take the input text, you can see that being passed in here, and tokenize it, i.e. chop it up into little word chunks. And then, so you can see the result we've saved in a batch dict, and then we're passing that into the model. And the resulting is saved in a variable called outputs. And now we need to get the data out of outputs. So we do outputs.last hidden state. And then we don't actually want the data, but I want to see the shape of what we're getting out. So if let's see, did I run this just now? So we run that, and then let's see what's in the output. You will see that it is in a tensor that has a shape 4 by 75 by 1024. So we understand 4 because we have 4 sentences. So we would expect to get 4 vectors back. And we know that this embedding model has vector size of 1024. So this also makes sense. What we expect is 4 by this, but not with the 75. Like, what's the 75? So what that is actually the length of these sentences that we're passing in tokenized. And we don't really want this. So this is what I mean by the actual output of the model is not in the shape that we want. And we need to run some additional code. And therefore, we need to define this additional function called a pooling operation. So we take in this data and we use pooling to reshape it into the shape that we want. So here we've defined the function, and then here we use the function, we pass in the outputs, in, and we save it to a variable called embeddings. So and then we normalize the embeddings because using cosine similarity, we don't actually really care about the length of the vectors. We only care about the angle between the vectors. So we can normalize them. And now if we run this, we can see the embedding size is indeed the shape that we want. And this is a more involved conversation than we have time for here, but just want to give you a little bit of intuition. Like, what exactly is average pooling? Average pooling is basically a way of reshaping the output of the model to a shape that you actually want. So in this, there are many different ways of doing pooling, but here you've got a 4x4 matrix, and let's say what you want is a 2x2 matrix. So you basically pool this and take the average, pull this and take the average, pull this, take the average, pull this, and so this is the output. It's like squeeze the dimensions down. And likewise, that's pretty much what we've done. We've squeezed the 75 into 1. And so we get 4 vectors of 1024 numbers each, which is exactly what we want. And then this one, it's basically comparing the cosine distance of these things that we fed in, so we can see whether it actually works. So you can see here, for the first query, the first passage has a score of 90. The second passage has a score of 69. And that's correct because this one is so much more relevant to this query than this one. And this is for the second query. You can see that the second passage should get a higher score than the first passage, which is correct. So now let's go back to our deployment process. So now that we've got the model, we've put some data through it, it works. Now we need to save the model by putting it into a tar file with some of the script that I showed you just now, and then save all of that stuff as a file on AWS S3. And if you haven't used S3, just think of it as like a place to put your files. So here, what it's doing is making some directories within the local space that this notebook is running in, and then it's saving the tokenizer and the model into these directories. And this, I think this doesn't take too long, so I'll run it. So after this is done, you will see this directory has been created, and it's got a bunch of files in it. Like this one in particular, PyTorch model.bin is the model. So you've basically like put all the things that they call them artifacts of your model into this directory. But like I said before, we can't just run a vanilla version of this model because we need to do that average pooling step. So what we also need to do is to put an additional file into this folder called inference.py. So here it's going to write all of this stuff into a file inside this code directory called inference.py. And what this is the code that will be run every time someone makes a call to the endpoint. So you can see here, we've put in that pooling function that it's going to need. We're telling the model that where to get the files, and then we've also put this you need to run the model, get the outputs, do the average pooling, normalize the embeddings, And then the API will then return a dictionary with a key called embedding vectors, and then all that stuff will be output to the user as the response. So if I've already run this, but basically it'll write all of this stuff to this file. If you double click on here, you'll see all of that there. And then step 5, which I will not run for you because it takes maybe 10 minutes, is we're going to package all of this stuff that I've showed you into a tar file. So here we've given the tar file a name. This could be anything. You can change it to whatever you like. And then we're adding all of the files within this directory into this archive, and then creating this. Sorry, I think that is this. Yeah. So if I run this, basically it creates this. Now that you've got that there, what you want to do is to then send this to S3. And so this part is just telling, giving the code information about where the file should go. So inside S3, they have these things called buckets. So I've created a bucket, but you can create your own bucket. And then let's see. Yeah, like the name of the model. And so you've basically got a URL to that S3 location. And then we're going to basically just use the AWS command line interface to copy this local file to our S3 bucket. So I won't run this because it takes a little while. And then once you've got all of that, you can do the deployment. And here we're creating a Hugging Face model class. So this model URL is basically the path to the tar file. So we're telling it where to get all of the code and the model. We've given it the role, blah, blah, blah. And then it will deploy the endpoint to a machine. And once you've run this, you've basically spun up a machine, and you're going to need to start paying for it. So if you're just messing around and you're not really going to use it, you should clean it up afterwards by deleting it. So after you run this, you will see. So after you've run that, this step 7, you will see when you go back into Sagemaker, and let's see, go to inference, and then you'll see models. You'll see an additional model deployed here. And then if you click into it, you will see, yeah, like where it's getting the model. Like this is where you save that tar file. Okay, so you've got a model, and then you've also got an endpoint. So if you click in inference endpoints, you'll see here it's in service. And sometimes after running that cell, it might take a few minutes for this to be in service. So if you click into it, you will see a URL. So this is the endpoint of your URL. And so let's copy that, and we can test it using Postman. So if you've never used Postman before, you can just go to postman.com, go to product, go to tools, and then here's the API client. So you can download that and install that on your computer. It's a very useful tool for testing out APIs. Once you're in Postman, you can come here, create a new collection, and then you can create a new request. So add request. And after you've added the request, you need to paste the URL. You need to set it to post. You need to go into authorization and go into AWS signature. And you need to put in your own access key and secret key, the AWS region, and put service name as SageMaker. I will put a link below to an article which explains how to get the access key and secret key. And then we can now, let me go back to this one where I've already put in all of my information. And so you can then go to body, raw, select JSON, and then put in something like this. So squiggly bracket, this is the format of a dictionary. So between these two squiggly brackets, your input always has a key called inputs. And then under inputs, you have a list, a list of sentences or passages as indicated with these square brackets. And then inside here, you can have any number of sentences that you want to get the embeddings back for. But note that these cannot be longer than 512 tokens. So for example, so now if I press send, I should get 3 vectors of 1024 numbers back. So here we go. See, you can see here, that's 1 vector, and then you can see that that's roughly the right size. That's the second embedding, that's the third embedding. So that's how you deploy a Hugging Face embedding model to AWS endpoint. Oh, I just wanted to remind you before we wrap up, if you're not very familiar with using AWS, you should remember to stop the instance that we spun up to run the notebook, so you're not paying for it if you're not using it. So you just select your notebook instance and click stop. And you can also just double check on the inference section whether you've got any models or endpoints running that you don't want to be running. If so, you can just select them and clean them up, delete them. And finally, we will have a few more videos coming up in the next week or two about how to design and create your own benchmarks so you can have something more quantitative to measure the effectiveness of all of these different embedding models for your particular use case. And we'll also look into a few academic papers to understand the various architectures for embedding models so you can make the best choice of the right model for you. And to make sure you don't miss out on those, please click subscribe, the bell, whatever. See you next time.